Hello and welcome to this video on test-driven development, and we're going to talk about what is called the Red-Green-Refactor cycle. So let's just jump right in and talk about, what is test-driven development and how do we use it? So in this video, what we're going to cover, we're going to talk about those three phases I just mentioned, the Red-Green-Refactor, describe the idea that we write tests first and what that really looks like in practice. We're going to apply the cycle to a simple little example step by step and explain why just enough code to pass is actually a discipline and not just laziness. I really enjoy the idea that we write just enough code to pass as laziness because of that old adage that if you give a lazy person a task, they'll find the most efficient way to do it. So, I don't know, be a lazy developer. But at the end, we'll talk about what test-driven development is not and some common misconceptions just to make sure that if you are either doing this in practice or you're in a professional environment where test-driven development is used, that you are actually understanding it correctly. So let's just jump kind of right into test-driven development versus the test after method of testing, which very different orders of operation. And I think software developers kind of learn test after whether they take a class or it just kind of is the natural progression of things, right? We learn to write code and then we learn to test code. Test-driven development really flips this order where we want to write the test first, watch it fail, and then write just enough code to make it pass. And for those of you who are developers who've been doing this for a while, you're like, that really sounds backwards. And it is. It's deliberately backwards. The whole concept of test-driven development is this constraint of writing the test first forces you to think about what the code should actually do before you have to think about how to implement it. And so you can see the steps here in our test after kind of traditional model. We design, we implement, we run, we debug, we make sure everything is working, and then we write tests. And that means the tests have to fit around existing code, which sometimes makes some very awkward tests or makes situations that are very hard to test. But in test-driven development, we first write a failing test. So instead of thinking about the code and what we want it to do and the implementation, we write a test that would test what the code should be doing. Then we write the minimum code that makes that test pass. And then we refactor, then we write another failing test, and we write minimum code. And so the design step is just entirely kind of missing because design emerges from the test. The code is testable by definition. And so again, if you're working in an organization that claims to use test-driven development, or maybe you're a student and you're getting out into the workforce and they bring up test-driven development, this is the fundamental piece that you need to understand so that you can talk about test-driven development meaningfully. So let's dig into the pattern I talked about. So red, this is where we're writing our failing test. We write a test for behavior that doesn't exist yet because that's the code we're going to write, but we haven't written it yet. We run it. It has to fail. Now, I say this, it has to fail. You can't write a test for code and then it passes because if the test passes, the test has to be wrong because the behavior already exists and we haven't written it yet. So if you are writing a test in test-driven development and it passes, then it almost makes you think that like the code that you think you need to write doesn't need to be written because the behavior of your code already exists. I know I'm laughing. That's it's such a funny concept. But we run the test, it has to fail. It has to fail for the right reason because the behavior is not implemented. Not like a syntax error or I mean, it could fail for an exception depending on reasons. But, right, we want the actual behavior to be missing because the behavior has not been implemented yet. Then, green phase. We write just enough code to then make that test pass. That minimum necessary. And it's not going to be the best code. It's not going to be a complete feature. It's just enough to get it to go green. And this is really a discipline. Resist the urge to write the full implementation. If a ridiculously hard-coded value makes the test pass, at this stage, that's fine. Because the next is going to make you generalize, and you're going to refactor, and you're going to improve. But we literally want the laziest minimum code that makes that test pass. And that's going to feel very contrary to the way that you have been writing code so far. Then we get into blue, which is refactor. So we clean up, but we don't break anything. So with your test pass, now you can go improve the code structure, rename, extract, simplify, get magic numbers out of there with confidence that if you break something, a test is going to catch it. And then this is where the value of tests really hopefully becomes concrete for you, because refactoring without tests is just guessing. Refactoring with tests is safe. So here is our cycle. We can see we go red, green, blue, until we are satisfied. Okay, so let's look at an example. And maybe you've seen the FizzBuzz application before. This is a pretty classic little example code logic problem for software developers. If you have never heard of or seen FizzBuzz before, please Google it and go look it up and look at some implementations. That's perfectly fine. What we're going to talk about is how we can do kind of the full test-driven development cycle on FizzBuzz. So the requirement is really that we have a function that returns the string fizz, F-I-Z-Z, for any entered multiples of 3. It returns the string buzz, B-U-Z-Z, for any entered multiples of 5. And then returns the full string fizz buzz altogether, no space, for multiples of both. And then returns the number as a string for anything else. So if it's not a multiple of 3, 5, or both, it just returns the number. So just let's keep it brief here. This is a Python example that we're looking at here on the screen. So in our red phase, we would, again, we don't have code. We're going to write a test. So we're going to write the test, returns number as string for non-multiples. So we would look at how we could take that number and return it as a string. Now I'm just going to assert fizzbuzz1 equals 1. Again, hard-coded numbers at the first red are perfectly okay. And so if I run this, I should get pass because I passed a 1 and I got a 1. All good. So then we can move on and add for multiples of 3. Right, so we assert fizzbuzz 3 equals our string fizz. That's a green pass. Then again, buzz for multiples of 5. So fizzbuzz pass 5 equals buzz. That's a pass. And then for both, we get fizzbuzz pass 15. We would get our fizzbuzz string back. That's a pass. Now we could refactor. So at this point, we can look at how we can correct the code to make it better. And we run and our tests still all pass. So no issues. So at no point in this exercise did we write code kind of from the idea of like, oh, for the future. Oh, because of this. Oh, I didn't think about the user doing that. Every line of code that exists exists because a test required it and a test checks it. And that is ultimately test-driven development. So hopefully that kind of gives you a handle of what it is and how it works. So let's talk a little bit about what test-driven development is not. So let's start with the idea that it's not about the idea of 100% coverage. 100% coverage is the idea that every line of code, every outcome, every scenario could have a test attached. Test-driven development is really a design tool, not a coverage tool. And that's why, going back to what I said at the beginning, the design phase doesn't exist like it does in the more standard form of software development, because we write tests to drive design decisions, not to hit some kind of metric. So we don't want to think about coverage. It's kind of a side effect, not the goal. It's not always the right tool. We don't always use test-driven development kind of for all projects, right? It works best for code that has clear inputs and outputs, where we have strong business logic, algorithms, validation. If you're trying to use this to apply to like infrastructure, UI, exploratory code, things like that, it's not going to work very well. You're going to just kind of get tangled up in the process. It is a tool and should be used in the right scenario. And then the idea that all tests first, all code after is not great. That becomes an insurmountable mountain, essentially. The cycle that we use, think of it as a very small and tight iteration. One test, just enough code, refactor, repeat. Not a big bang test suite followed by essentially a big bang implementation. So really just think about small bites, small tests. All right, so to wrap things up, here are our key takeaways. So in test-driven development, this is the idea that we write tests before we write implementation code. It is a three-factor, three-phase system, with red being the phase where we write a failing test that ultimately defines what we want, green, where we write the absolutely nastiest minimal code that you've ever written in your life, go crazy, to make it pass. Then we refactor, clean up with confidence, and the tests ultimately catch our regressions. Each iteration is small. We get one behavior at a time. We keep repeating this cycle until we're happy with the solution. And as you move forward, you have a little async task to complete the FizzBuzz kata so that you can get some kind of hands-on examples of using test-driven development that you can then implement later. So in my next video, we're going to talk about why test-driven development produces better designs and ultimately where it fits in the DevOps kind of ecosystem. So as always, reach out with any questions and I will see you in the next video. Thanks so much.